So why having these two seemingly a bit redundant methods, right? Idea is number one, when we have an at, it ensures that the value that's being returned is that particular scalar type that is being stored there. Right? Most of the time, our cells will contain scalar types. For example, age would be an integer, salary will be a float, name will be a string. They are all scalar types. Actually, pandas can store structured types in the cells as well, though it will make it very complicated and um, maybe unnecessarily. Usually, there are better ways to design your data model so that the efficiency in pandas can be exploited without having the cells storing complicated structure types. Right? So, in most settings, we'll be using pandas to store different scalar types in the cells. The at and iat ensures that when we get it back, it won't be a data frame or series. For sure it's going to be a scalar type. So that's great. The assurance is nice. Number two, another purpose is that the readability of the code that we always emphasize. The .log and ilog, oftentimes, because we know all programmers after studying this understand that they are very flexible. They can read one or many cells, one or many rows. But at and iat, if you use them in your program, your loop, your code, definitely signifies that at that point in your code, you're only interested in getting one cell. So that automatic documentation is very powerful. It's very good. It makes your code, the intention very clear, right? There is no what happens if the variable changes. What happens if 6 is a variable and it gets a value that is 4. That means there's only one cell. You want a data frame of one cell and you didn't take care of the type, something like that. So it's going to make the code a little bit more burdensome because you need to handle the potential uh, data frame of one cell kind of situation. But the at and iat makes it clear that your code only deals with scalar type at that point. So let's move on to the other type, the last way that we would like to talk about today, which is to get and set a particular data frame using different means. And this is a very powerful means that you have to know. It's very cool. It may look a little bit confusing and hard to understand, but it's important to know this. Otherwise, the rest of the powerful features and capabilities of pandas cannot be utilized. So the idea is this. And because I've got nice color graphics here, I want to just talk about this first. So before we go into the actual spider. So the idea is this. What if I have the intention to select very ad hoc kind of cells? So the yellow cells indicate my ad hoc selection. Maybe it is because it's user selected, kind of at random. Maybe because there's no systematic formula that is easily described by a slicing range, like 0:6:3. No, there's no easy way, because what if I want this? It's not easily describable. I might as well just code it with 6 df.at, something like that. But there is actually a more systematic way to do things. It may not necessarily be more efficient. Usually it is quite efficient, but it sometimes may not be efficient. But we're not just dealing with efficiency, we're dealing with the clarity of the code that is much more important. So the idea is this. We can handpick these, but there's no easy way to do that. What if we can just say, I'll put a false if I don't want that cell. So I don't want this one. I put a true because T just refers to a shortcut for true. So I put a true if I want that cell. And then false, and then true, right? And then false throughout, like this. You see that? So I'm kind of describing what I want. arbitrarily because I have the flexibility to check any of the character to tick it. And likewise, we do the for the second row. Okay. And notice here we have true, false, true corresponding to tick, cross, tick. Yeah. Okay. So how does this work? We create a pandas data frame. So a data frame can just be created like that using a list, our usual familiar Python list of lists. Okay, so by default, if we have a list of lists, the internal list, the second level list, refers to the row. So this is exactly pictorially also correct, yeah, because it's the row, comma, row. When we create this, we also need to give optionally, all right, in this case, since I already labeled them, the column labels, I give the column labels. So the list is going to convert this string automatically into a list of letter A, letter B, letter C, and so on. So we'll have that. And then we do something that is very, very amazing. We're going to derive a df2 here. Okay, we're going to derive a df2 here using original data frame, which has the same size and shape. So 2 rows and 10 columns. Yeah. So we pick them, and we are going to just uh, enter this data frame of true and false in the selector. So remember that when we say df square bracket a selector label, right, selects the entire column with that label. But now we are saying df selector an entire data frame, you know. So what is going to happen? What is going to happen? Is Python going to give us error? That's the best part. No, it's not. In fact, it is encouraged. It's the right way. It's a very powerful way that Pandas supports. And that's called, whatever you call it. You can call it a mask, the true false, true false. So df underscore true false is a mask data frame. It will return. Okay, here's what it returns. This expression will return a data frame that has the same shape as the original df. So it's a copy of df. And it has the same values of df only in the yellow boxes. The rest that are not selected because they are false will be set to none, nil. Or in the integer case, a none or nil is given by nan, which has the same feel and behavior as Python's none, N-O-N-E. So in this case, a stored version of a none for integer floating point is nan, N-A-N, and it represents not a number. Not a number. Don't try to even think of it as infinity or minus infinity or whatnot. It's not the same. It's just not a number. So it's a storable floating point value. You can assign it to a variable, and it represents not a number, and it's not equal to anything. Okay, so this nan is correctly reflecting that nothing is selected, so it's not a number, and so that position is not a number. So the rest are the numbers that are being selected. Okay, so likewise we can do it on series. So we have a series of labels 0, 1, 2, 3, 4, 5, 6, and we are able to say pick on 1 and 5. 1 and 5. Now, because the series is short, we can actually just do I don't know, a slicing of 1 colon what? 1 colon 6 colon 4, you know, so that will do the job. But let's pretend that it's so complicated that we have to handpick 1 and 5, right? So then what we do is just say false, true, false, 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 true, false, which is false, true, false, 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 and true, false. Exactly as what we wanted. Then when we do this, we say the original series, all right, have a selector, and the selector is a series of the same shape, except the contents are all trues and false. Only the true ones will be selected. All right. So it creates a new series SS2 of length 7. Why length 7? I thought we only have two cells selected, but it is going to be of the same shape, same dimension as the original series. So the original series has 7 elements, it will have 7 elements. And it will only have valid numbers copied from SS for all the true positions. And all the false positions will be NaN as usual. So same behavior as data frame. Now it'll be quite cumbersome if we receive a series that only has two cells because we selected only two, right? Because that would be very different in behavior for data frame. For data frame, we understand because how are you going to compact it? Are you going to shift the two cells below to which two cells on top? It's not defined, right? There's no easy way to do this because every selection is arbitrary. So it's best to maintain the same shape. That part we understand for data frame. And to maintain compatibility and standard of processing, the series acts in the same way. It returns the same dimension as the original SS series, and only those with true uh, values being put in will be selected. Okay, so I hope that's something that you can think through a little bit again and understand fully before you roll up your sleeves and start hacking on the Python pandas. All these are very important, and where our subsequent discussion will build on top of these concepts.